All right, Math 2, here we go. We got lesson 1-3, the triangle sum theorem. Make sure that you put your name and your period up top. So our question today is why does an exterior angle of a triangle equal the sum of the two remote interior angles? We're going to actually mathematically show that, but I want you just to explain in your own words why that's true. So why does the exterior of an angle equal the sum of the two remote interior angles? So you'll see that in a little bit when we get to exterior angles theorem. We're going to start off with the triangle sum theorem. And you'll probably remember this from previous classes. Whenever you have a triangle, the inside angles add up to 180 degrees. So the triangle sum theorem says the sum of the interior angles of a triangle are always equal to 180 degrees. So if you add up the three inside angles of a triangle, they always add up to 180 degrees. Let's do a little bit of a picture here. So I'm going to make a triangle. Now I am going to cut this side short a little bit over here, and you're going to see why in just a second. My pen's running out of ink again. Why does it always do this to me? Okay, there we go. So, yeah, you can see that good enough. All right, so this is going to be angle 1 inside of our triangle. This will be angle 2. This will be angle 3. And then this side out here, you see how this kept on going? This one is a different type of angle. So the interior angles are 1, 2, and 3. So those are interior. So the interior angles are angle 1, angle 2, and angle 3. So when it says the sum of the interior angles, it's talking about those three angles. Those should add up to 180 degrees. So we should know at this point that the measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3 is equal to 180 degrees. That's what the triangle sum theorem says. But this angle out here, angle 4, that's what we call an exterior angle. An exterior angle, angle 4, that's when we just take one of the sides of our triangle and extend it beyond the triangle. So I could have made another exterior angle up here just by going farther up here, and that would have created an exterior angle. Or I could have just gone down here, and then that would have created an exterior angle out here. So you just extend one of the sides of a triangle, and that makes what's called an exterior angle. And that brings us to the exterior angle theorem. Okay, so exterior angle theorem. Remember, theorems are just the rules of math. I always forget how to spell theorem. I think I got it right. All right, so the exterior angle theorem says, okay, so exterior angle is 4. So the theorem says this exterior angle is equal to the sum of the two remote interior angles. The remote interior angles are the two angles that are not linear pairs with that one. So what this one says is angle 4 should be equal to 1 plus 2. So the exterior angle and then these two would be remote interior angles. And the remote interior angles are just the angles that are not linear pairs. So we can't use angle 3 because it's linear pairs with that exterior angle. So the rule is an exterior angle is equal to the sum of the two remote interior angles. So in this case, we know that angle 4, that angle out there, or the measurement of angle 4, is equal to, so the exterior angle is equal to the sum of the two remote interior angles. And like we said, the remote interior angles are angle 1 and 2. So it's equal to the measurement of angle 1 plus the measurement of angle 2. All right, so what we're going to do is prove that these two theorems are correct. If it says theorem on it, it can mathematically be proven. So we're going to prove that the exterior angles do work every single time, like we said they do right here in this equation. And we know that the sum of the interior angles is always going to work. So let's do the proof. Of the exterior angles theorem. All right, so I'm going to use this diagram up here to prove that angle 4 has to equal angle 1 plus angle 2. All right, so the first thing that I'm going to do is I'm going to say that the measurement of angle 3 has to be equal to, or not equal to, the measurement of angle 3 plus the measurement of angle 4, these two make a straight line. And anytime they make a straight line, because they're linear pairs, they're going to have to add up to 180 degrees. So I'm going to say, okay, the measurement of angle 3 plus the measurement of angle 4 must equal 180 degrees. Why does it equal 180 degrees? Because those two are linear pairs, and linear pairs are supplementary. These two make a straight line. So I'm going to just say the reason over here is linear pairs are supplementary. Let's just sup. That's good enough. All right. Now the other thing that I know is the triangle sum theorem says that angle 1 plus angle 2 plus angle 3 equals 180 degrees. So I'm going to write that down. Okay. Measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3. Those all also equal 180 degrees. And the reason why I know that is because of the triangle sum theorem. So this is the triangle sum theorem. Now let's look at this. These two are equaling 180, and then all of these also equal 180. So if this one equals 180 degrees, and this one equals 180 degrees, they're both equal to the same number. That means these two have to be equal to each other. So I can say, since they both equal 180, that they're equal to each other. So I'm going to write the measurement of angle 3 plus the measurement of angle 4 is equal to this one, measurement of angle 1 plus the measurement of angle 2 plus the measurement of angle 3. Now remember, this side was equal to 180 degrees, and this side's equal to 180 degrees. So all I'm saying here is the 180 degrees is equal to 180 degrees, which is obviously true, because this one was equal to 180 degrees, and this one was equal to 180 degrees. That's actually called the transitive property. It looks like substitution, but it's called the transitive property. Anytime two things are equal to the same thing, that means they're equal to each other. That's what the transitive property says. All right, I've almost proven what I need to prove. Notice how both of these have angle 3 on both sides. Well, I can just subtract angle 3 from this side and subtract angle 3 from this side, because I'm allowed to subtract the same number from both sides. So I'll subtract those two from both sides, and what am I left with? Well, angle 3 goes away over here, and I'm left with the measurement of angle 4 is equal to, on the other side, angle 3 went away, and I'm left with the measurement of angle 1 plus the measurement of angle 2. So we use the subtraction property to get there. And we have now proven the exterior angles theorem, because the exterior angles theorem said that angle 4 equals 1 plus 2. Here I got angle 4 equals angle 1 plus angle 2. So now we know definitely it works every time because we've proven it mathematically. So angle 4, the exterior angle, is always going to equal the two remote interior angles. All right, now we're going to prove the triangle sum theorem. All right, in order to prove the triangle sum theorem, we're going to use parallel lines like we did in the last lesson. So I'm going to have a set of parallel lines here. So here's one parallel line, here's another parallel line. Okay, so there's one parallel line. There's another parallel line. I'm going to call this line M, and this line N. Okay, I'm going to put 3 points. Oh, they're going to be parallel, so I need to mark that. So that's parallel, and this is parallel. I'm going to put 3 points on the top. I'll call them A, B, and C. So here's A, here's B, and here's C. So there's 3 points on top, and I'm going to put 2 points on the bottom. So this will be D, and this will be E. All right, now I'm just going to make a triangle out of B, D, and E. All right, so there's a triangle. There's my triangle right there. And I'm going to mark the 3 interior angles. Angle 1, angle 2 up here, and angle 3 down here. All right, so what I want to prove is that angle 1 plus angle 2 plus angle 3 equals 180 degrees because that's the triangle sum theorem. All right, so I'm going to prove it mathematically now that that is always going to be correct. And since these two lines are parallel, and then we can just look at this one line here, this is a transversal, right? You remember transversals? Well, when we have two parallel lines and a transversal, we found out that alternate interior angles were congruent. So that means that this angle here should be equal to this angle here because alternate interior angles are congruent. So I'm going to write down that the measurement of angle 1 is equal to the measurement of angle ABD. So that angle right there. Okay, now using this transversal over here, angle 3 and this angle up here are also alternate interior angles. And since the lines are parallel, we know that alternate interior angles are congruent. So these two angles have to be congruent because they're alternate interior angles. So I can say that the measurement of angle 3 is equal to CBE. So the measurement of angles CBE. So the reason for these two right here is that alternate interior angles are congruent. All right, we're getting there. All right, now let's look at the top. This line up here is a straight line. That means it has 180 degrees in it. Now, this angle, and this angle should all add up to 180 degrees, right? So this one, and this one, because together they make a straight line. So I can say that the measurement of angle ABD plus the measurement of angle 2 plus the measurement of angle CBE, so this one right here, should equal 180 degrees. And my reason is because that's a straight line, or a straight angle. And straight angles equal 180 degrees. So now I know, okay, these three angles up here should be straight angles. Okay, now what I want you to see here is angle 1 is equal to ABD. So what I'm allowed to do is instead of ABD, I'm allowed to plug in angle 1 because they're equal to each other. And now I know angle 3 is equal to CBE. So now I can say, okay, this angle 3, I can plug in over here because they're equal to each other. CBE is equal to 3. So my next step is, instead of ABD, I'm going to write angle 1 because they're the same angle, plus angle 2, plus CBE, we just said, was angle 3, and then they're equal to 180. We just proved that the interior angles of a triangle are always going to be 180 degrees. And we did it using alternate interior angles. It's always going to work. All right, before I let you go, I'm going to show you what one of your homework problems is like because it can get a little bit tricky. So, here's our example for today. Sorry, these notes are going a little bit long, but they're a little bit longer than normal. We just have to deal with it. All right, so in triangle ABC, segment AC is extended through point C to point D. All right, then we know that the measurement of angle CAB is equal to 3x plus 17 degrees. We know that the measurement of angle BCD is equal to 10x minus 5 degrees. And we know that the measurement of angle ABC is equal to 3x plus 2 degrees. All right, that's all we're given on our homework tonight. So there's no picture. So if we're not given a picture, it's hard to visualize. Oh, and we're supposed to find the measurement of angle ABC. So if they don't give you a picture and it's hard to visualize, draw your own picture. Well, how do I draw my own picture? Well, let's start here. In triangle ABC, okay, there's a triangle. It's called ABC. I'm going to draw it. So triangle, doesn't matter what size you make it. Here's my triangle. Boom. Okay, they told me that this one was named ABC. So I'm going to call this one A. I'm going to call this one B. I'm going to call this one C because they said it was ABC. There you go. So in ABC, got it. Segment AC, okay, that's the bottom, is extended. Okay, that means extended means they make it longer. Okay, where is it extended? Problem. It's extended through point C to point D. Okay, so this one they say it's going to go through C to point D. That means point D is out here somewhere. All right, let me draw that. So they say they're going to take AC, extend it through, which means it's passing C, to point D out here. There we go. Now we've got a picture of what they want us to do. And now we can fill all this in. CAB, CAB, that's this one right here. So this is the one that's supposed to be 3x plus 17. BCD, BCD, that's this angle out here. That should be 10x minus 5. ABC, that's this angle up here, 3x plus 2. All right, now I'm ready to go. This looks like the exterior angle theorem. I've got this exterior angle, and it's equal to these two together. So I can say that 10x minus 5 is equal to these two added together by the exterior angles theorem. So I'm going to write 10x minus 5 is equal to 3x plus 2 plus 3x plus 17. Okay, I'm going to combine my like terms over here. So 10x minus 5 doesn't change. 3x plus 3x is 6x. 2 plus 17 is 19. All right, now let's see. I'm going to subtract 6x from both sides. And I get 4x minus 5 equals 19. I'm going to add 5 to both sides. I get 4x is equal to 24. Divide by 4 on both sides, and I get x is 6. Now, the problem didn't ask for x. It asked for ABC. All right, so ABC is equal to 3 times x. X we just found out was 6, plus 2. So we've got ABC is going to be 18 plus 2, which is 20 degrees. And now we have our answer. Done. All right, so you have some problems like that. You'll also have, I think, at least one problem that looks like this, that walks you through the proof of the triangle sum theorem. And that's your homework. Make sure that you answer this question. Why does an exterior angle of a triangle equal the sum of the interior angles? We covered that in the proof. You just have to take this and put it into words. That's all I got for you. Thank you very much. Bye-bye.